Okay. This spinner right here is the same spinner from the 6.1a lesson. I believe it was 6.1a. Has the same proportions. We're going to use that again. The first thing I want to explain is my first statement. And this might be weird for you. Y equals x plus x is not y equals 2x in this class. Oh no. Okay, because we drilled it into your heads for so long, but it's not. Let me explain to you in this extremely embarrassing scenario what x plus x and what x and 2x are in statistics. Okay, so pretend I'm a little kid. I know that's hard to do. What with me and my kid animal thing. And I'm at a fair or something, okay? And I walk up to the spinner and I go, okay, and it lands on 5. Thanks. My embarrassing part. Okay, and then I spin it again. And it lands on 4, and I add those two numbers together. That is x plus x. So the two things are not necessarily the same. It's spin plus spin. So spin 1 plus spin 2. Okay, how is that different from 2x?
Instead of 5, and then 2.
Yeah, okay, so I just walk up to the spinner one time. I get a 5 or something, and then I double it. If I just times it by 2, but it's only one spin doubled. So this is 2 spins added versus 1 spin doubled. Yeah, but doesn't. Okay. So 2 spins added. 1 spin doubled. Okay, so now what we're going to see is what happens with the distribution of x plus x. So all the different possibilities and their probabilities. I'm going to make a probability model, but I'm going to start with the 3D. It's not 3D, this is 2D, and then arrange all of my options. Okay, so let me explain what I'm doing here. This is x plus x, meaning I have a first spin and a second spin. In this box, my first spin was a 2 and my second spin was a 2, and I add them together and I get a 4. In this box, my first spin was a 4, my second spin was a 2, and I add them together and get a 6. Are you with me? Okay, so 7, 6, 8, 9, 7, 9, 10. Okay, that is a list of all possible outcomes I could get from spinning the spinner twice and adding my 2 spins together. Okay, now we're going to calculate probabilities based on this picture here. So if you guys, I don't know if you remember, but the 5 was 50% chance. And the 2 was 30% chance. And the 4 was 20% chance. Does that ring a bell to you from the other day, like last week? If you want me to, I can go back here. It said 30% chance of spinning a 2, 20% chance of a 4, 50% chance of a 5. That's where I got those from. Okay. All right. So we're going to put those same probabilities down the side. And then this essentially becomes an area model. So 0.3 times 0.3 is 0.09. This means you have a 9% chance of spinning a spin, getting a 2, spinning another spin, getting a 2. Do you understand that? Okay. So 9% chance of 2 spins, adding them together, getting a 4. Okay, you guys see what I'm doing? Okay. 0.06, 0.15, 0.06, 0.04, 0.10, 0.15, 0.10, 0.25. What? Good. Okay, so now we're gonna add all of these in here. So there's actually a 0% probability of getting a 5. You can't really get a 5. Okay, 6. There's 2 boxes that you can get a 6. 0.12, yeah. Okay, there's 2 boxes that have 7s. Yep. 0.04. 1 box for 8. Yep, 0.2 for 9. Yep. Okay. Because this is 4, 6, 7, 6, 8, 9, 7, 9, 10. There's no 5. Okay, I want you guys to, on your own, find me the mean of y, the standard deviation of y, and the variance of y from using your graphing calculator. Just run and get one from the 20 I have over there. Help each other, remind each other how to do it. Yeah. You can do it either way. You can put 5 in or not put 5 in.
It doesn't matter if it's above or not.
Nope. Sure get 5 a lot. Right, Justin? In this particular scenario, you get 5 all the time.
There.
Wow. Well,
I took the notes when I was there. I don't remember.
Oh, there.
okay. I have no more time for this. I was supposed to take like 45 seconds. Okay. Would anyone be willing to offer what they got for the mean of what? 7.8. I'm gonna go here, 1.8385. There's a reason I'm gonna go there. Just hold on that thought. Okay, and then variance. $3.38. Okay. I wanted to go out this far so that this 3.38 would come out as evenly as possible. Okay. All right, now Jake remembers because he just said it. Back from the other lesson, what was the mean of x? 3.9. And what was the standard deviation of x? Okay, I'm gonna find it. Okay, so the mean was 3.9, standard deviation was 1.3, and the variance was 1.69. Okay, my goal in the next few seconds is to figure out how I can find the mean of adding two things together, standard deviation of adding two things together, and the variance of adding two things together without doing all of that table and graphing calculator and stuff. So what pattern can I pick up from this to get this in a lazy fashion? I don't want to do all this crap. Okay. Remember that we're working with y equals x plus x. Okay, so if y equals x plus x, how do I get 7.8 from 3.9? So x plus x. So 3.9 plus 3.9 is 7.8. So what I'm saying is, if you have this just one spin, you can actually get this by just adding the mean twice. Correct. Okay, hold on that thought. It does work for the variance though. So this is 1.69 plus 1.69, which is why I took that decimal out as far as I did. Okay, so moral of the story here, very close. It's okay to add means together. Means are safe to add. Woo, woo. Okay, variances are safe to add. Standard deviations?
Or not, say that.
No.
No.
Okay, this is what you have to do for standard deviation. You have to, and I'll show you on here. There's your standard deviation. Okay. I'll explain. Don't worry. Okay. Let me explain what you have to do.
Yeah.
Light bulb starting to come on. Okay, so x plus x, mean plus mean, no biggie.
Yeah.
Variance, x plus x, variance plus variance, no biggie. Okay, now standard deviation. You have to take the standard deviation, convert it to variance. So this, then add it, because it's safe to add variances, and then square root it to get it back to standard deviation. Okay, let me say that again. You have to convert it to variance, then add them because it's safe to add variances, and then square root it to get it back to standard deviation. Okay, we're gonna write it out in words so that you guys can stick, yeah, and I have little formulas for you too. Okay. These are not going to be lengthy things we write. We're just gonna put formulas in here. So don't stress about it. Do you want me to zoom in and just do part of it? Okay. Like this, better? Having technical difficulties. There was a new version of Zoom this morning. Now the recording thing's on the right instead of the left. Also, this is supposed to be a little Y. I don't know what happened to it. There we go. So we're gonna come in here, when we're done at the bottom of this, by the way, we're halfway. So mentally prepared. Because we have to do the subtraction. Okay, now. This is the mean of x plus y. Mean of x plus y is the mean of x plus the mean of y. You can just add them together. So just add means. When you have a mean problem, this is the mean of one thing and the mean of something else. What would the mean of them be to combine together? Just add them. No big deal. There's this like dumb little saying, it's stats. The mean of the sum is the sum of the mean. Meaning that you could just add them. Okay. Variance. Same thing. Totally safe to add variances. Great. Okay, now not so much. I want you to know that this little formula has 3 steps going on inside it. You see these 3 little steps? So it's a little formula here, but it actually has 3 things happening at once. It's taking the standard deviations and converting them to variances. Then it's adding the variances, and then it's square rooting to get it back to standard deviation. It's just its own little deal, but it does all 3 things for you at once. Okay, now you need to know what happens if you need to multiply or divide by something that, like order of operations wise. What this is saying is if you have to multiply by something multiply before you add the means together. So multiply the mean of this, multiply the mean of that, and then add them. This is like an order of operations formula here. I'm assuming we don't need to write down variance because you can see what would happen already. You just multiply and then add them, but standard deviation gets weird. You have to convert that also, not just the plain constant in there, it has to be squared also because of order of operations. Are you excited? You look just stoked about it. Okay, when you're ready, flip your notebook or whatever, because we're gonna make another 9 box. Yep. It's gonna be for the x minus x. Mm-hmm. We don't actually need to do the 2x, because if you think about it, we did it with the transforming. What happens when you multiply or divide by a constant? Why?
Why?
Children, please, if you could just act interested in the subject. I spent a lot of time on this, it'd be awesome. What is after this? It's only Monday. Since you're ready, Jamie, can you describe to me in words what happens with the spinner with x minus x?
This is the two things. This is one of the two things added, like, each other, the two things minus each other.
Yes. Okay, so that means that the first spin was a 2 and the second spin was a 2. 2 minus 2 is 0. 4, excellent job. 4 minus 2. Yep. 5 minus 2. 2 minus 4. Yeah,
That's one.
this is wrong. This is not wrong. This is wrong. This is wrong. I read it as a 3 for some reason. I read this number instead of the 5. Because I'm trying to multitask. Okay, now, next question. Does it make sense to you that the areas in the box are gonna be the same as the other areas on our previous one? Because you're multiplying the same decimals. So we can just sort of copy those off of ourselves from the last box. As long as you believe me that they'd be the same. It's really just the outcomes that change. Okay, now I was talking to Luke about this last week, and we were talking about when we create a probability model, how to order the things, because we were talking about how to find the median. And I was like, remind me to talk about that next week. If you're going to use it to find the median, which we are not, but if you were, you'd want to make sure to list your outcomes from least to greatest. That's what I'm trying to say. So we want to start our table at -3. Does that make sense? I just did this wrong. Yeah, yeah. Which would be 41, 38. That's 29 plus 9, 38. 38. All the zeros on the diagonal that Jacob so nicely tell us they were on the diagonal. Okay. Now, can anyone explain intelligently why the subtraction does not have one that is 0? Or why they're different? There's the same number of options. What makes this different? True, that's not what I'm looking for, though. What I'm looking for is the word commutative. Anybody remember the commutative property? Yes. So like, when you add things, the order doesn't matter. 2 plus 5 is the same thing as 5 plus 2. And when you subtract things, it actually does matter. That's why we have options for all of them, because subtracting makes them different numbers. 5 minus 2 is different from 2 minus 5. Anyway, okay, now can you guys go on the graphing calculator and find me the mean, standard deviation, and variance again? Yeah, doesn't that make sense? It's right in the middle of with the most probability. Okay, but that should not be nearly as surprising as the standard deviation. It's the same. Which means that the subtraction didn't make it less spread out. It was the same amount spread out. There's no reduction in spread because it's subtraction. Okay. So where did this number come from? If the mean of the spinner itself was 3.9, 3.9 minus 3.9. So if your problem is a subtraction problem, is it okay to subtract the means? Yes. Okay, so the mean of x. Yep. Okay. The I really can't tell you how much I appreciate you bantering around this concept. It's great. It actually makes me happy. Extremely happy. Okay. We know this standard deviation and this variance are the same thing as the other one. This one is 1.69 plus 1.69. Okay. So the variance of subtracting is still plus. Why? Because it doesn't give you less options. You still have the same amount of options as when you plussed. Look at all of the different options. It's still 9 boxes. Exactly. Okay, so add variances. We never subtract any kind of measure of spread, really. Okay, then predict for me off of what you know, what's the standard deviation formula going to be? Yep. Anyone want to take an intelligence deck and what the formula for this is going to be? So this is the mean of AX minus BY. And remember, it's means. Nice. A mean X minus B mean Y. So multiply first, then subtract. It's okay to subtract means totally fine. Okay. Now, what about standard deviation? Yes. It's the same as the addition one, yes. Yeah, this is the last little bit. We just need to do one. So that we know what to do with an actual problem that is not Mrs. Talbot's spinner. That I did the spinner noise for. It's also the same noise I used to illustrate Santa's list unraveling, unrolling. Can you picture Santa's list?
Yeah, like, are we gonna have a Christmas?
I was just gonna ask that.
Are we gonna have a Christmas tree?
I worked so hard on the Halloween test, I don't know. I mean,
It made more sense to
I heard that.
Am I wrong?
What?
Am I wrong?
What?
I said the scariest part of my
Oh.
Halloween is my test grade coming out.
Yeah, it's because that's you can see smile too. That would have been the scariest part of your Halloween. Oh, goodness, no. I got freaked out with my stepson just telling me about it. He was telling me the different scenes from it. And I was like, just stop talking, just stop talking. But it made him feel better to tell me about it because he was so freaked out. And he's like, we tried to go to the store after, but then we couldn't. Because then, like, if anybody smiled, we were freaking out. We had to leave. And then his friends were like smiling at each other. And then I don't even know. I'm not a horror movie fan. I'm a Disney movie fan. I did like the Muppets Haunted Mansion. That's a scary one. You should watch that. Got Gonzo. You know how scary Gonzo is. Are you making fun of my movie choice? Okay, are you guys ready?
Yeah.
All right, so. All right, so this is like an actual problem. We have this is the formula, 2x minus 2y, and these are all of our stats. Okay, it's a subtraction one. So we want to compare it to this. And so this is going to be the mean of, and I'm going to put it like this first. 2x minus 2y. Because that's what t is. So I just took t and replaced it with 2x minus 2y. And now I'm going to go here. So 2 times the mean of x. I'm right here. So the a is 2. 2 times the mean of x. What's the mean of x? 5. Do you see where that came from? Minus 2 times 7 equals 10 minus 14 is negative 4. Okay, now this one's going to be standard deviation of 2x minus 2y. I'm going to look at this thing. Okay, let's go slow. A is this little baby 2 right here. So 2 squared times 3 squared plus 2 squared times 2 squared, which is, this is 36 plus 16, square root of 52, which is 7.211. Like a pluggy in the formulas. Okay, you guys ready for your joke?
Yeah.
I can't remember if it's good or not.
No, bro, you don't get to live this down. This is staying out, get it down.
Okay. Did we Do we do this? Do we decide that combining x plus x or x minus x is not equivalent to doubling outcomes? Okay. Do we calculate the mean variance and standard deviation of the sum or difference of random variables? Okay, there's the homework and do you guys get why this is funny?
Yes, yeah, I know. That's the metal.
Yeah, that this guy doesn't know what he's talking about because the best of the best. Yeah, it's not up to- He did not take AP stats clearly with that, and then that person is also really. Wait, I wasn't gonna use that language. I was just going to say uneducated about the bell curve.